Hello and welcome to ML with AP. Today we are going to check out top 20 Panda tricks which every data scientist should know. Well, 20 almost. I have sneaked in a couple of cool tricks which are related to Python notebook or core Python. I hope you won't mind. Let's start with the first one. The first one is actually not directly related to pandas, but it's so cool. Let's see what it is. Many a times what the need is that when we output, especially in a Jupyter notebook, we only wanted to see the last output. If we are training our machine learning model, we do not want to see all the epochs. Maybe we wanted to only interested in the error analysis for the last epoch, right? But the Jupyter notebook will print everything out. Let's see what I mean. What I'm doing over here is very simple. Okay, I'm printing I just to show you that how it looks if I print 1000 numbers sequentially. Friends, do you see this over here? How ugly it looks? But what I am interested really is in only the last output. What I should do? I should import a library, IPython display, and I should do import from there. From that package, I should import clear output. Clear output weight is equal to true. This is the argument which we have to pass. You see what happened over here? I'm only seeing the last. Everything else is flushed out, right? I'm only seeing the last. If you do not mention weight is equal to true, let's see, it is going to flicker a bit. See? And that's why this weight is equal to true is very important. So once the number generates, it flushes it out, next number generates, and hence it is not flickering. Okay, it's so cool. The first time I saw it, I said that, oh, I have to use it. It makes my Jupyter notebook look so better. The number 2 trick over here is specifying this is related to pandas, specifying the maximum number of rows or columns to display. So when it comes to Jupyter notebook especially, right, sometime our pandas data frame can be very large. It could have multiple features like 100 or 1000 features and millions of rows. Are you going to display everything? We should minimize like how much it should fit on the screen. And the way to do that is, let me do a pd.read CSV of a CSV file which is there on my file. It is called messy_csv.csv, and I'm reading it. It's nothing but your IMDb data set. Okay, so I have read that over there. Now you see, I have to scroll it and it looks weird, right? Let me set the option. So I can set the option, display option for maximum rows and display option for maximum number of columns. Let me set it that I only want 20 rows and maybe let's say 8 columns. Okay, let me do my df. Do you see that over there? Okay. Let me just extend this to 200 or 2000 for that matter. You see that? Let me do the df. If you see, all my 2000 rows are getting printed over here. Okay, this data frame actually has 1000, so it will only print till the maximum, which is 1000. But suppose it would have 2000 rows, it would have printed, and I'm printing how many? 8 columns only. And when I am printing only 8 columns, in that case, if you notice, there is ellipsis or the 3 dots which you are seeing, right? These 3 dots reflects that my columns are being collapsed, right? So I'm only displaying 4 on this side, 4 on that side, 8 columns in total, right? So number 8. So you can very well control how many rows and columns you want to display. Cool, right? If you, in case you want to know like what is the current setting in my notebook, you can always fetch display max rows or display max columns. Let me just show you. It should come as 8 over here. 8, right? You can always query that back as well. The number 3 trick is subsetting with query. Now we already know that subsetting is, or filtering is, one of the features of most important features of pandas, right? So if you want to filter out or subset a particular pandas data frame into and based on certain criteria or conditions, Then what you do, typically this is the query which you wrote, right? Which you write. So in this particular case, what is happening is I want, and this is my Pandas IMDb database. So number of votes are greater than 2000 and the series title is equal to The Godfather. Fetch me that particular, those observations or those rows which matches with these criteria. Okay. Now, one thing, friends, you have to see that if the criteria are getting bigger and bigger, we are writing unnecessary, and it looks very clumsy that I'm writing this and this. You can write maybe for one or two conditions you can write, but suppose there are multiple conditions over there. What I suggest you to do is, anyway, let's run these cells anyway. So this is my df.head, top 5 rows. And I'm running this condition. I fetched one row, The Godfather. Obviously one row will match because IMDb has the unique, it's movie database, so Godfather will appear only once, I guess. Okay, anyway, that's not the point. The point is, if I use df.query, then instead of writing such a long query, long and slightly ugly query, what I can write it in a much simpler format as this, and it will fetch the same result. Let's see over here. See, it fetched the same record over there. Cool, right? So instead of writing a big ugly query, what you can do is you can pass the parameter of your query in df.query and it will fetch you the result. Move on. Number 4. What is number 4? Changing the number of decimal places in a column with round method. So suppose you want to change the decimal places, like you have a feature, and in that feature, it's a numerical feature, and you want, and perhaps, let's see over here. Okay, we have some numerical features, right? Like number of votes or gross income or gross revenue which that movie had generated. What I'm doing over here, just to showcase this, I'm dividing the number of votes by 10,000 so that it becomes a decimal number, right? Let me do that. And when I did a head on that particular column, see, everything is divided by 10,000, it becomes decimal number. But these decimals are 4-5 digit decimals, which looks ugly. Suppose you have to round it off to 1. What you will do? On that particular data frame series, because it's one column, so it will be data frame, it will be series, not data frame. Dot round 1 dot head, and head is just to fetch the top 5 records. So if I do a round 2, that means to round it off to 2 significant digits after decimal. So it is rounding off to 2 significant digits, right? This is the way you can round off a numerical feature or column in a data frame. Number 5, want to remove, and this is again not directly related to Pandas, but I think everyone should know. I first saw someone using it for the first time, and it appeared so cool to me. I'm sure that it is very common, but just as a repeat, as a reminder, just understand this. Okay, let's say I have a list, and this list are mutable, non-unique, right? Order data sets, right? So 1, 5, 3, 6, 3 can repeat over here, right? Suppose our job is to find what are the unique elements or the unique values in this list. What is the quickest and the easiest way you can find it? Obviously, you can write a loop, or you can iterate through it, and then you can find, or you can write a lambda or a function and you can do that, right? There are multiple ways you can do that. One way which I think is very, very cool is to utilize set data set, right? Or set data structures from Python. Now set, as you know, are mutable, so they can be changed. Mutable means it can be changed. It is unordered, and only one number can exist, right? Unique. So there cannot be 2 3s in the set, right? So what I'm doing is I'm passing my list, test list, through a set constructor. So this became a set. Once I'm transforming my list into a set, what will happen? All my unique values, the duplicates will drop off from here. Again, I am passing it through a set list constructor to make my set back into a list, right? Let's run everything so that we can see. See? Finally, my list, what you're seeing, 1, 3, 5, 6. It is only the unique values of the list which it is carrying. Now let me explain this to you by doing this over here. You see, this is my original list. Now let's see one by one. I'm passing it through a set constructor. See, this is a curly braces, so it tells you that it is a set 1, 3, 5, 6, or you can do a type of it if you are not sure. Then type of it, the data type. See, it is a set, and once I pass it through list, this particular thing, see, it becomes 1, 3, 5, 6, and the type of this also you can check. It's a list type, right? I hope you got that right. So if you have to find unique values from a list or drop the duplicate values from a list, the coolest trick which I have seen is passing it through a set constructor back to a list constructor, right? Okay, number 6. This is again related to Jupyter Notebook, but it's so cool, right? Suppose you want to fetch some file which is there on your system, on your file system, but you do not know. It could be a Python file or a Jupyter Notebook, and you want to fetch. You know that something is there. You know how Windows Find works, right? Similar to that, and you can run. The coolest part is that you can run all the shell commands without going to the command line. If you are using a Linux or Mac OS system, you have to go to the Linux shell prompt or the Mac OS shell prompt, and to do that, but just with a bang, this is called bang or exclamation, whatever you want to call that. Once you put that in Jupyter Notebook, actually you can run all the commands as if you are running it on the shell. So let's see. I know that there is an IPython notebook, and this is just a grep command, right? Which I would have run ideally on the shell. So I'm trying to find all my IPython notebooks, right? All the files which match this criteria, and find me the pattern which is scikit star. So what it will do, it will find me all the files in my current folder starting with scikit, right? And I'm doing that, right? See, it will fetch. If I have to make a temp directory, mkdir, right? This is the shell command to make a directory. I'm making a temp directory, or let's say temp1. I made a temp1 over here, right? I will do cd to temp1. I can go over there. Now, one thing to note, friends, is that with cd you have to use percentage and not exclamation. And similarly, you can actually run all the commands over here, whatever you want to run with this exclamation or bang. Okay. Here's number 7. Suppose you have a big Panda CSV file, and if you want to read, do you want to read all the really big Pandas, really big CSV file through Pandas read CSV and build a big data frame? No. Maybe you want to divide into chunk, and you want to see the first chunk, that how the data frame looks before loading the entire data frame. Pandas read CSV method gives you that option. So a parameter which you need to pass is chunk size, and chunk size takes the number of observations or the number of rows which you want to pass. So let's say I have this messy CSV.csv, which is nothing but my IMDb database data set, which is there on my local file system. If suppose I want to read only 100 records at each time, right? So I'll pass a chunk size as 100. Let me run that. Over here, if you see, after every chunk, and this, what I'm doing is, I'm doing a PD read CSV chunk size 100, but I'm reading it in chunk, and then I'm printing this chunk. So after every 100 record, I'm printing a dash dash dash. So the last dash dash also appeared over here. And at the 900th one, if you would see, yeah, you see this? So all my data frames is getting printed one by one because I'm for looping over there, right? If you want to see that what is the data type of the chunk, it's a data frame. So you can be sure that when we are dividing this into chunk, what we are getting a smaller 100 row worth of a data frame, right? And which is stored in chunk, and then I'm printing chunk and iterating it over there. Okay, let me print the last chunk. Can someone tell me what it will print? Think. Obviously it will print the last chunk, right? because we are iterating it over here. My last chunk will be, because my IMDb database has 1000 records, it will be from 900 onwards to 100 rows, right? Because my chunk size was 100 over here. Got it? Cool. Let's move on. The trick number 8, reading messy CSV file using clever CSV. Now, as a data scientist, we cannot get away from CSV file. We encounter CSV file all the time. Some CSV files are nice and they will load properly. Some other CSV files are messy, where obviously when you are reading it, it will throw some, if you are doing a pd.read CSV, it will throw some exception. Even if you are using the Python native's CSV module, it will throw some exception because the format of the CSV file had some character or something which our pd.read CSV is not able to comprehend. Then what you do, you open that file or you go manually over here and you fix those problems and then you again run it, right? It's a time-taking thing. But clever CSV is a package, right, which comes to the rescue over here. Now, what is clever CSV? Let me show you by an example. Suppose I have created a messy CSV, and as I was telling you with Bang, I can actually do a cat. Cat is, I will print from the file, right? I'll print the file. Let's say I have a file like this, a CSV file. Now, friends, if you notice, it's a messy file, right? So there is a character over there. I am escaping it, but there is a Michael O. Richards Jr. So there is one more comma, right? One more comma, right? And there is a nan value, there is a comma. So this is not your typical nice CSV. This is the weird type CSV. Let's see if I run it plain vanilla pd.read CSV, what will happen? It throw an error. What does the error say? That expected 3 fields in line 6 saw 4. What does it mean? It means that it is treating this also as a delimiter. So it is treating 1, 2, 3, 4. They were expecting 3, 1, 2, 3, 1, 2, 3, but he got 4 in the last row because of this, although it is being escaped through this, right? Oh, by the way, these are all characters of my favorite sitcom, Seinfeld. Anyway, how we should use clever CSV module? Now, what we do is through clever CSV, it will generate you the code. What it does is, it does read it parses your CSV file, messy CSV file, and then it has inbuilt knowledge, and it has seen a lot of such messy files. So it has the knowledge that, okay, how to parse this file. It can intuitively guess or do a good job at guessing that what should be the dialect. When I say dialect, that what is the format of this CSV file which people are passing, and then it will pass it will generate a code for you, the code which you can write, and then the code will have the parameters which needs to be passed. So let me show you what I'm doing. My messy CSV file, I'm passing it through a clever CSV file and I'm asking it to generate the code, and I'm doing it in the command prompt, right? Command prompt. Let me generate it. So what it will do, it will throw me an output like that clever CSV version, this. Obviously, you have to do a conda install of clever CSV. Then I'm doing an import clever CSV. This part is the code which it is generating, right? I have pasted it over here, the same code. If you notice, then it is telling you this by parsing this, the clever CSV has parsed my messy.csv, and it knows that the delimiter of this CSV file is comma, one thing. The code character is this thing, and the escape character is the escape character, right? So if I run this particular command and do my df1, see, it has no problem of reading this into a data frame. Cool, right? So you do not have to invest so much time and energy going through manually and fixing those weird places on the CSV file where some error is occurring, right? You pass it through clever CSV generates a nice code, one-line code for you. You run that, you import into your data frame, and you're done. Cool? Number 9. This is again not related to directly related to pandas, but I think people should know about it. If you're a good data scientist, you should know about it. So shallow and deep copy. I don't know how many of you know. Python by default, it's a by default the copy will be shallow in nature, right? Because the objects are being referenced. The objects are not the actual location of the data where it is put. If I am saying, let's say first list, and I'm defining a list over here, the list, this particular list is stored somewhere. First list is not storing these. First list is only a pointer or a reference to that particular list in memory where it is being stored, right? This is how pandas works, right? Now, if you do a copy, the Python native copy, what it will do is it will only do one level deep copy, and I will show you that what it means. Suppose we have a list like this. This list, if you notice, the first element is actually a list inside that. So it's a heterogeneous list. First list is also a list inside that, right? And then the second element, or the first zero, this is zeroth element. This is first element is a character, second element is a character, third element is a character. Let's say I did a copy. Now I make it in a second list. Now my second list now should be equal to my first list, right? No problem. Okay. Now I'm going to modify my first list, zeroth element, and after that second. So second will be 0, 1, 2, right? This element. And this element, this 3 I'm trying to modify. With what? With 999. Let me do print first list, print second list, right? You see what happened over here? You see what happened? The first list, I only modified the first list, but my second list also got modified. Why? Because pandas didn't recursively copy the deeper objects inside this particular list, right? What it did is it created a new reference only for this, but the reference which was related to this was not copied. It is still reference to the first list, right? The reference to this first element of the list or this nested list was not copied. Okay, so it didn't recursively copy. That's the shortcoming of copy. In that particular case, that's why once I wrote first list, my second list also get overwritten. Okay, what if I do a deep copy version? Now I'll import copy and I will do the same thing. I will repeat deep copy. Let's see. In this particular case, my second list, this nested list, got unchanged, right? Remain unchanged. Why? Because what deep copy will do, it will recursively create new object references. Okay, so this object also got a new reference. Okay, when I'm creating a second list using deep copy, this also get a new reference, right? Okay, or a copy of this was also created rather, and hence it was not changed. I think in case, one thing friends to know, to be mindful of, if you want to really copy a deep copy or a true copy, you should always use deep copy, not copy. If you use copy, it will always do a shallow copy. Okay. Okay, here is the number 10. Use display to show multiple data frames in Jupyter Cell. Whenever we print a data frame to see how my data frame looks like, whether all the operations which I've done has reflected or not, I have to do it in multiple cells. Suppose you want to compare next to each other. How you'll do? You'll use the display method. You display method and you pass the DF or the data frame inside that, and it will stack it one on top of other in the Jupyter notebook. See how cool it is. Now you can easily compare in case that was the original intention. Number 11, and unique. Counts the unique values of a series or data frames. What does it mean? Let's see. So what was my DF1? My DF1 is this, right? Jerry Seinfeld, age, sex, and this, the name of the characters over here, and their age and sex, right? Now, if I have to do a unique count, and unique, that how many unique values are there in this particular series. If I'm doing a DF1 sex, that means that I'm talking about this particular column or series, I'm doing n unique. How many are there? 2. What if I run the n unique on the complete data frame itself? See what happens. Name, we have 5 different unique. Obviously they are names and they are all different. So we have 5. Age, we have 3. Why we have 3? We have 244, 140 and 139 and 1 nan. Obviously it ignored the nan and it calculated that we have 3 age. Again, gender, we have 2 genders, male and female over here. So it represented. So n unique run on the data frame gives you a very quick view of how many unique values are there in a data frame or in a column or in a series, right? Number 12, data frame dot explode. Now this is also a very less known thing. Let me construct a data frame first and then show you what I meant by that. If I show you my data frame, then if you notice, and I constructed this data frame using this dict, right? This nested list over here, this nested list didn't get expanded, right? So Mahesh, gender is male and work is service, comma, biz, right? If you do a df.explode, on what? You have to pass a column. And where I'm doing? I'm exploding work. Okay, I'm expanding work. And let's see what the new df will become. It expanded the service and biz into 2 rows, right? So this particular list, because since I passed work in explode, this has exploded or expanded and created instead of 1, 2 rows, right? It has blown it up. It has expanded it up, right? It has exploded it up. And so I have Mahesh male service, Mahesh male biz, right? So there will be some use cases for this where you have to do this particular trick. Correlation. Now, Pandas numerical columns, you can do the correlation. Let me construct df1 and df2 over here. So my df1 is this, my df2 is this, and I want to do a correlation of df1 with df2. What? My A will get correlated with A, my column B will get correlated with column B, and let me print what it says. It says that A with df1 and df2, between df1 and df2 has correlation of 0.94. It is very close to 1, obviously, because if you see, notice 1, 2, 3, 4, 1, 2, 3, 3, highly correlated. Only one value is changing, otherwise everything is the same, right? Okay. Column B, and this is element by element correlation, right? So over B, 2, 3, 4, 6 was there, 2, 2, 5, 4 is there. The correlation is 68% or 0.68, right? So this, you can find the correlation between 2 numerical attributes or 2 numerical features of the same data frames. You can do all those things, right? With using the function or method corwith. Number 14, normalized value count. Now we have already seen, let me see. So I have a sample csv.csv. Let me see what it is. Okay. So it's a data set of countries with their literacy and income levels and all those things, right? Over there. Okay. Not important. The important is what we are going to do with this. Let's say we do the status column is developing. So if we want to do initially what we do, if you have to count the unique value of this, what we do, df.status.value counts. Okay. How many values? So developing is 2426 rows. Developed has 512 rows, right? This already we know that what value counts does. This will print you how many values of a particular category is, right? So you know. But given this doesn't tell you the whole thing, right? Maybe you wanted to know that what percentage is developing, what percentage of the country is developed inside this, right? What you can do is you can do value counts and pass a parameter normalize is equal to true. When we say normalize is equal to true, what it will do is instead of printing these absolute numbers, it will print the percentages. Let's see. See, the developing is 82%, developed is 17%. Cool, right? Instead of printing the absolute number, it will print you the percentages. If you pass on the parameter, normalize is equal to true. Number 15, create a data frame from Clipboard. This is also very cool, right? Let me see. So if I have df And what I need to do is, suppose sometime it's a small data frame and you're copying it from either a table on the internet or a Excel sheet or somewhere, right? And you have kept it in the clipboard. You do not want to again save into open a CSV file, save it, do pd.read_CSV. You do not want to do that. You have it in the clipboard. You have done Control C and you want to just read it into a data frame. How you can do that? The method is read clipboard underscore. Let me show you. Over here, I have a small data frame, right? What I will do is, I will just do a copy of it. It has come to my clipboard, correct? Now what I will do is, I will run this. See? Data from the clipboard to data frame, and it has come. Let me see that if I want to change. I'm changing the 4th row and the 1st column to John Doe. Okay, I have changed. Let me see what is my new data frame over here. Instead of Michael, it has come John Doe over here, correct? Now DF to clipboard, the reverse is also possible. So my data frame is now over here in memory. If I want to take it to the clipboard, I can also take it. See, I took it to the clipboard. What was the original value in clipboard? Michael 1, right? This data frame. I've changed it to John Doe. I again did this. What will be there in my clipboard? This particular data frame, because I'm doing data frame dot df dot to clipboard. Let me paste it over somewhere and show you. See, John Doe came. So what happened over here? The data frame got copied to the clipboard and I just pasted it over here in the Excel sheet. Cool, right? Number 6, rank. Suppose, what is the best example? I think this is the best example. Rank is like your order in the sorted list, right? That is rank. Rank in the class means, okay, the first rank who got the highest marks. So we sort it by marks, and then we say that the first is the highest one, second is the second highest one, and things like that. I'm creating a new data frame over here just to make things simpler. Students and marks. Now I'm creating a new column called rank, okay? Based on what? Marks. And then I'm passing the method dot rank, ascending is equal to false. Let's see what will happen. It will append a rank, df rank over here, okay? Based on what? Marks in the ascending order. So 95 is the first. So Suresh became the topper. The second topper is Ramesh. Third is Ramya. Fourth is Mahesh. And fifth is Sunita, right? So in case you have to append a column of any numerical feature in an ascending order, right? And you have to see that which is the first, which is the second, which is the third highest, right? You do not have to do a lot of manual juggling. Remember that you have a method called rank. You put rank and automatically, and you can append that to the last column and it will give you the result. Number 17, one-hot encoding. Now many a times in machine learning models, we have to do one-hot encoding. Pandas we can use a standard sklearn one-hot encoding, also one-hot encoder. But Pandas also give you a feature. What it is? Get dummies, okay? So suppose I have in my initial data frame, this particular data frame, I'm adding a gender also, okay? Let me print my data frame. My data frame, I have included a gender column over here, right? Male, 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 female, female. What I will do is gender is categorical, right? It has two categories. I want to do it one-hot encoding or get dummies, right? If I do that, and then I join that hot encoding with the original data frame, right? I joined that with df.join one hot. I got one hot over here. I joined it. So it appended it over here. When I printed my data frame, it printed female, male, two more columns with one hot encoding. So suppose you have to run your machine learning model and doing one hot encoding, you can do it through get dummies, okay? Natively in Pandas. Otherwise, you can use scikit-learn also. Number 18, continuous to categorical. Let's say you have, sometime what will happen is that you have a continuous variable and you have to convert into categorical for some reason, right? Maybe to pass it through a machine learning model, right? Because, and for better performance or whatever be the reason. Let's say we have now our original data set, this particular data set over here. Suppose we have marks. This is the column. So I'm trying to, what I will do is this is the numerical feature, right? What I will do is I will convert this numerical feature to a categorical feature. How will I do that? What I will do is I will take the data frame or this series, this feature or this column marks, and I will bin it. Bin it how? Binning means you are putting it in the basket or the buckets. So 0 to 40 is the one bucket, which is fail. 40 to 70 is another bucket, which is pass. 70 to 90 is another bucket, which is A grade. And 100 is excellent. Okay. And where I'm putting, I'm appending a column in the same data frame as grade, right? And I'm running it and passing it through pd.cut. pd.cut is the method through which you can bin or you can convert your continuous variables into categorical. You can, after that you can plot histogram or do whatever, right, with that. Let's see what happens. When I did a df on that, based on my marks column, my grade is also attached over here, right? You see, so 80 was A because 80 belongs to the 70 to 90 range, right? A. So I got Ramesh got an A grade, and similarly the grades are attached over here. How cool is that? Suppose you have the marks, which is a numerical, and you want to convert those marks into categorical. This is pd.cut will do the job. It's so easy. Number 19, reverse row or column order. Now this looks very cryptic and weird, but it is true, and I think it's widely popular also. So with integer based location, right, ilog, you can access the data frame row or column using index based, right? So index is like 0 1 2 3, and I, when you specify this, student becomes 0, marks become 1, rank become 2, and blah 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 blah. Now as in the Python list, everything is reverse index also. It's zero based indexing from top to bottom, or from front to last, from the start to the finish. From bottom it is -1 indexing. So the -1 is the last element, right? So if you have to reverse a row, what you need to do is df.ilog : -1. That means you are starting from the last, going to the first, decreasing by -1, right? This is what it means. If I did this, let me see, my df is this. What is my df? Rev row or reverse row? It will reverse the order of the rows over here. See, my 0 went to the last, and 1 went to the after that, 2 3 4. Suppose I have to do the column. What I will do, because since in the ilog I can reference all the rows. When it comes to column is after comma, right? From the last column to the first column in decreasing order, right? And I'm trying to store that into a df rev call. See, my columns, what was my initial column? A student to grade, it became from grade to a students, right? See, it had changed. Okay, number 20 and the last one. Make Pandas native toy data frames. Many a times we have to create our own data frames. In this exercise also I have to create some toy data sets and all, and which is a lot of typing, and you have to pass through a dict and all those things, or create a list or a set and then do certain things, right? Pandas by default provides a utility, okay, where you can create toy data sets. Let me create that. Okay. So if you see over here, tm.makeDataFrame.head, and I run this, and if you see over here, okay, this is a future deprecation warning. We can ignore that for the now. Okay, it has generated a data set. You can specify how many columns and rows you want, right, over here with this option. Okay, and then let me print the head 10, right? So it is generating some number in a data frame, a numerical data frame, right, with numerical features and some indexes, right, over there, which you can use, which you can play with, right? So suppose if you have to do a regression or some analysis on a toy data set, you can do it over here, or you can learn Pandas, you can do it over here. Now Pandas by default gives a lot of these capabilities to make toy data sets. If you have to see again, all the methods which are exposed, or the attributes or the methods which are exposed by this particular object, you can do a dir and do that, right? But there are attributes also and methods also. If you want to get only the methods, right? So make, anything which is starting with make over here and which I have printed over here, all these are like you can create. So let's say make missing data frame, so some missing value should be there in the data frame, right? Make float series data frame, right? You can make float series. Make custom data frame, make categorical index data frame, make boolean index data frame, right? You can make time series. Suppose you want to play with the time series, you can create a time series data frame. Make time series instead of over here passing that. Let me just copy and see if that works. Okay, so instead of make data frame, I'll make time series data frame. So suppose, see how it created. So this is my time, this is a time series data frame, right? This is my time and this is my continuous variable, right? A continuous feature. It generated a time series data frame, right? Let's try one more thing. Maybe, which one should I read? Missing data frame. Okay, let's try missing data frame. Okay, so it will give you some NaN values, right? So suppose you want to play around with the NaN values and all and how it works, you can generate this. Cool, right? Okay, with that being said, I think I have come to the end of this all 20 tricks related to pandas. Mostly there were some tricks which were related to Python notebook, core Python. I hope you won't mind it, and those were also cool. I hope you liked this video. If you liked, I do have a favor to ask you, please do subscribe. That will mean a lot to me. And with that being said, I'll see you all in the next video. Bye.